Hello everybody, this is Mr. Ray. Today we're going to be doing a lesson on solving linear equations. I'll be talking about what they are, what the purpose of solving linear equations is, and the process to do it. And then we're going to be doing about 10 or so examples from easy linear equations to the more difficult. So uh, the first thing about linear equations is um, basically the word equation means it's got an equal sign in the middle of the math statement. Um, you've got a left side equals right side. Okay, so I'll create the most basic linear equation. We'll talk about what linear means in a while, but I could create an equation x plus 1 equals 2. It's an equation because it has an equal sign. It's got a left side, x plus 1. It's got a right side of 2. Now, this equation is pretty straightforward. You just basically, the whole purpose of solving an equation is to find the value of the variable, which is x in this case, that makes the equation true. So in this example, you could basically figure that out in your head, that x has to be 1 um, for that to be true. And you can always check your answer by plugging it back in. If I change x back to 1, which it's supposed to be, 1 plus 1 is equal to 2, so you know that that's correct. Okay, so that's a very basic linear equation. Um, I'll I'll create a more difficult one, which will be our last example at the end. We won't solve it right away, but you can tell by this that it's quite a bit more complicated than the first one. You can see I've got some divisions, I've got multiple terms, and looking at that, it can be pretty intimidating. What am I supposed to do? And in this case, you can pretty much forget about guessing. It would take you the better part of a day to come up with a guess that works, um, and you'd be very frustrated. So what we're going to do today is come up with a strategy for solving any linear equation, basically a process that does that. Um, and again, just like this one here, we want to do some work and then end up with x equals some number, um, which if we plugged it back in here, this whole thing would be equal to 2. Okay, so a couple things about any type of equation. Um, I can understand some students looking at that getting anxious, but if you go into the whole process of solving equations, think of it as a challenge, okay, which it is, but a challenge like a puzzle, like how can I figure out what the value of, in this case, what is x that would make this true, okay? And again, I'll write that out because it's so important. Solving equation means find the value of the variable that makes the equation true. That's sorry. That's what makes that's what solving actually means. Makes the equation true. I'll just shorten that. Okay, that's the whole purpose. Find the value of x that makes this true. Um, Now we're going to do this. How do we do this? Well, uh, I've given you a step-by-step guide. So I'm going to say we're going to talk through this guide as we solve some of these equations. Use the guide, which gives you the process or the steps for solving. Um, and anytime you have an equation, I want you to think of an equation, like I said before, you've got a left side, an equal sign, and a right side. Now, an equation is like a scale. Okay, these old-fashioned scales uh, that had two trays and kind of a thin wire in the middle, and call this thing a fulcrum. So what we used these types of scales for in the old days was you want to measure the weight of something, so you'd put that on one of the sides, and then you'd use these predefined weights. You know how much they weigh. You put them on until the two scales are balanced. So we're going to use that same idea. So in this, for equations, this left tray would be your left side of the equation. The fulcrum, or the middle point, would be your equal sign, and your right tray would be your right side of the equation. Okay, now if you think about equations like a scale, it becomes a little more straightforward what you can and can't do. So if you think of this scale, right now this is saying these two things are the same value. Okay, so if I want to do something to the left side, say I want to add 2, well, if I only add 2 to the left side, all of a sudden the left side goes down, the right side goes up, they're no longer equal. So anytime we're working with equations, you have, whatever you do to one side, you have to do to the other. So if I add 2 to the left side, I add 2 to the right side. If I subtract 10, I have to do it on both sides. If I multiply the left side by 2, I multiply the right side by 2. Otherwise, the equations do not stay balanced or equal anymore. Okay, so that's going to be a real essential part of what we're doing. Think of an equation as like a scale. Okay, and the last thing I'm going to put here for our strategy is we're going to use inverse or opposite operations. And we'll see a lot of this, but basically what this means is if I want to get rid of a plus 2 on one side, I'm going to do the opposite of adding 2, which will be subtract 2. So if I want to get rid of for example, this one here, if I want to get rid of this doing the process, I would subtract 1 from both sides. Okay, so when I subtract 1 from here, these two cancel. That cancels out with the plus 1, and then I have 2 minus 1 here, which would be 1. So that would be the methodical process way of doing that one, other than just guessing. Okay, so that's what we're going to be doing. So if you can keep these things in mind and don't stress yourself out, it can look intimidating. Like I said, that one probably is causing some anxiety right now looking at that, but you'll see that when we get to it, it's not so bad if we follow the steps. So at this point, if I bring back this this step-by-step guide that I've given you, it's really a process. So I've highlighted the important terms here. So the first step is always get rid of fractions. Fractions always make it more difficult. So the first step is just get rid of the fractions. Once we're done that step, all the fractions are gone. Then we get rid of the brackets. And then the rest of it will kind of be more obvious. We're going to simplify each side. So for example, on this side here, I've got a minus 3 and a plus 21. I can combine those without actually having to do something to both sides. So if I see anything that I can simplify like this, I'm going to do it at this step here. Okay, so that minus 3 plus 21 becomes 18. And then this we'll describe as we get it, but basically you're getting your equations so that you just have an x term or a variable term on one side and a constant term on the other by the time you get here. And then you might have something left over like negative 3x equals negative 24. This one we just divide. So dividing will be the last thing you do. Okay, don't try to do that too early or it's going to cause some problems. Okay, so whenever you're doing these questions, pull out this sheet if you want to remember what the steps are. Okay, so we're going to be going back to that as we look at these examples. So example number 1 is x minus 5 equals 20. This is a lot like the one we did at the beginning. The little numbers are a little higher. So we're going to do this the methodical way. So if I look through all these steps here, there's no fractions, there's no brackets. I can't simplify either side at all. But when I get down here, I can see I only want variable terms on the left side, so I'm looking for x's over here to fix, and there's nothing there, so I can skip part 4, but part 5 says eliminate any constant terms. A constant is just a number by itself. Okay, so what I'm looking here is on the left side here, I only want x's, so that minus 5 or subtract 5, I want to get rid of that. So we, like I said before, we do the opposite operation. So if you do this the long way, what I'm going to do to both sides is add 5. So I'll put a little box around there just to show you all I've really done here is add 5 to both sides. You don't have to do this if you're confident in what you're doing. These two will actually cancel each other out. You're just left with x, and then you simplify 20 plus 5 is 25. And that is your answer. You found the value of x that makes this true. We can check that by plugging in 25 where we see the x. 25 minus 5 is 20, so we know that's correct. Okay, checking is always a good thing with solving equations. If you're doing any kind of assignment or test, you pretty much can check your answer every time by plugging it back in, seeing if it works. Okay, let's do example 2. We have 3x equals negative 42. So again, if we go through the checklist, no fractions, no brackets, nothing to simplify. We basically got an x term on one side and a constant on the other. So we can fly right through here, and we basically get down to the bottom where we have something very similar to what we have in the example. So when we get down to this, when we have a coefficient, or sorry, a multiplier with the variable term is equal to a constant, well, all we do is we divide both terms by whatever the coefficient or the constant part is. So we divide that by 3, and don't forget we have to do the same on the left side. Okay, so I basically divide both sides by 3, and when you see that, those cancel each other out because 3 divided by 3 is just 1. So we have x equals, and then negative 42 divided by 3 is negative 14. And if you plug that back in, you can see that 3 times negative 14 is negative 42. So that's correct. Okay. So we call these types of equations one-step equations because basically we just did one step and it was solved. Okay. Let's go to example 3. We've got negative 2x plus 4 equals 14. Okay, now you can see this is going to be more than one step because we've got this term here that we don't really want, the plus 4 on this side. We want just x over here. So we always take care of that constant term. So if I'm going through this checklist here, basically I don't have to do any of these first 3 steps. I don't have to do the 4th one because there's no x over here. But the 5th one, I want to eliminate the constant term, the plus 4. Okay, so I'm going to do that by the opposite of adding 4 is subtracting 4. So we're going to subtract 4 from both sides. So again, you don't have to do this, show this, and there's different ways of showing it. I'm comfortable with whatever way you want to show it or not show it. So you can see that doing the opposite will cancel those 2 out because plus 4 minus 4 is 0, and you're just left with negative 2x equals 14 minus 4 is 10, and then we just divide both sides by whatever's in front of the x. That's the last step. So we get, sorry, yeah, that's a negative 2. Be careful of that. That happens quite a bit, forgetting the negative sign when you divide. So these two cancel each other out. We get x equals negative 5. And we could test that. We could plug that back into here. Negative 2 times negative 5. Negative times negative is positive, so that's 10 plus 4 is 14. So we know that that's right. Okay. Let's go on to the fourth one. We have a W. Now, we've been using X's all along until now, and that's pretty common for the variable that we get, but you got to be prepared to see any type of letter here. In this case, what our goal is to find the value of W that makes this true. So again, when we go through our checklist, we do have a fraction this time. So what we need to do to get rid of the fractions, since we only have one fraction here, the way we get rid of that is multiplying by everything by 3. So I'll just put that in front here to describe what we're doing. And it's important that you show this step, okay? So everything gets multiplied by 3. So when I multiply a fraction by 3, the 3 goes on the top, okay? And then don't forget about the other two terms here. Just because they're not fractions doesn't mean we don't multiply them by 3. So that gets multiplied by 3, that gets multiplied by 3. Remember, equations like a scale, so whatever we do to one side we have to do to the other, and that includes all the terms. So if I'm multiplying one side by 3, I multiply all the terms by the 3. Okay, so when I simplify this, you can see the 3 divided by 3 is 1, so that just changes to a W. Sorry, that's a minus sign. 13 times 3 is 39. 7 times 3 is 21. So you can see we've nicely gotten rid of the fraction. And now we can just say, okay, the only thing that's in the way of getting W by itself is this. So we do the opposite of subtracting 39, and that would be adding 39. We do that to both sides. These two cancel out. So I should put that. Okay, those two cancel out, so I just get W, and then 21 plus 39 is 60. And that's our answer. If you want to check it out, W is 60. 60 divided by 3 is 20. 20 minus 13 is 7. So we know that's right. Okay, so 4 examples done. Let's go to the fifth one. Now this one's a little tricky. It looks simple, but it's harder than it looks. And hopefully, a lot of times when I give this question to a student, they'll just say, oh, we just multiply both sides by 5. Well, if I multiply this by 5, I'm not going to get rid of the 5. I'm going to get 25 over x. So that's going to make it worse. So there's 2 ways of doing this one. Okay. This is the first method. This will be the second. I'll give the one that I would, well, actually either one is okay. If I rewrite 5 over x is equal to 4, well, if I can change this 4 into a fraction, okay, and since it doesn't look like a fraction, but any integer really is a fraction, it's just the integer over 1. So if I wrote it like that, then I could say, well, this fraction is equal to that fraction. Okay, now the problem with this question is the x is on the bottom, the variable's on the bottom. It makes it tricky. That's the hard part of this one. So the first strategy here would be if you have a fraction equals a fraction. Well, if I flip these two fractions upside down, we call that taking the reciprocal. The reciprocals of these would also be equal. So I could just flip these upside down, and I get x over 5 equals 1 over 4. And then all I do is, like we did before, if I want to get rid of the divide by 5, so I'm going to multiply by 5. So I get 5x over 5 equals 5 over 4. These 5's cancel, and I get x equals 5 quarters, or 1.25, which is exactly the same. Okay, so that's one way of doing it. The other way of doing it would be, so if you think about it, if that had been a 3 on the bottom, if it had been opposite, I would have just multiplied by whatever's on the bottom. Okay, Usually that's a number, but not in this case. So I could say let's multiply by x. Okay, so that's what we're going to do here. I'm going to multiply the left side by x, and when I do that, that goes on the top, and the x on the bottom was there already. And then when I multiply the right side by x, I get 4 times x. And you can see in this case, the x's cancel out. Okay, so I get 5 equals 4x. Now, if you're like me, you'd like to have the x's on the left side, so you can easily just switch the two sides if it makes you more comfortable. And then you can say, well, now we're at the division step, we're just going to divide both sides by 4. And when I do that, the 4's cancel out and you get x equals 5/4, which is 1.25 again. So you can see you get the same answer, two different strategies. Whichever strategy you like best is fine. Okay. Now let's try another example. This time, the next few won't be as hard as that one. We have some brackets this time. Now, again, there's a couple ways of doing this one. If we buy the set of instructions on this guide, there's no fractions here, but there are brackets. So if we do get brackets and we've already taken care of fractions, in this case that means we're going to take that 3 and multiply it with the x and multiply it with the 1, distribute. So that's going to give us 3x plus 3 is equal to 12. Brackets are gone. So now I can't do any simplifying on the side. So what we're going to do is get all the x's on one side, well they already are, and get the numbers on the right side. So I want to subtract 3 from both sides. These two will cancel each other out, and I get 3x equals 9. And then we just divide both sides by whatever's in front of the x. This time it's positive 3. And we get, those cancel out, x equals 3 is our solution. Okay, I didn't check that one, but it is correct. This one I could easily plug in. So if x was 3, don't forget you got to do inside the brackets first. 3 plus 1 would be 4. 4 times 3 is 12. So we know that's right. Okay. Let's go to number 7. We have another fraction this time, but this time, well, the variable is w, but it's on the top, so we don't have that situation. We have w plus 3 on the top, so that makes it a little bit different. So again, if we go through our guide, we see a fraction. So how do we get rid of that fraction? Well, we're going to multiply everything by 4. Okay, we're going to multiply this by 4 and this by 4. So how do I show that? Well, I multiplied the numerator, the top, with 4. Okay, and then to balance it, I have to multiply the right side by 4 as well. So here the two 4's cancel. So I get w plus 3 is equal to 8, and now it becomes pretty straightforward. We're just going to subtract 3 from both sides. Okay, that cancels out, and we're left with w equals 5. Okay, and we could check that again. If w is 5, that would be 8. 8 divided by 4 is 2, so we know that's right. Okay, so I think we've got 4 more to go. The last one will be the one that I showed you at the beginning. So let's try this one. So this time we have x over 2 plus x over 3 is equal to 15. Okay, now what makes this a little different is we've actually got 2 terms that are fractions. Okay, so we want to get rid of both of these. So the issue here is if I multiplied everything by 2, I'd get rid of that, but I wouldn't get rid of that. If I multiplied everything by 3, I'd get rid of that 3, but not the 2. So I have to pick a number, we call it the lowest common multiple, of 2 and 3. So what's the smallest number that I could divide by 2 and also divide it by 3? And that's that's going to be 6. I can divide 6 by 2 and then 6 by 3. So that's what we're going to multiply everything by. So on our next step on the tops, I'm going to multiply everything by, so I could put brackets there to show it was already there. And this is a 3. And don't forget about the 15 here. It still has to get multiplied by 6. Otherwise, the equation isn't balanced. Okay, so we can do a little bit of canceling here. These don't get totally eliminated, but 6 divided by 2 is really 3. And 6 divided by 3 is really 2. So if I just write what we've got left over here, I've got 3x plus 2x equals 15 times 6 is 90. Now here's where I haven't had to do this yet, but we can combine these two together. We just add the coefficients, we get a 5x. 3x plus 2x is 5x, and now we're down to the last step. We just divide everything by the coefficient, and we get x equals 90 divided by 5 is 18. Okay, and if you check that, 18 divided by 2, that's 9. 18 divided by 3, that's 6. So 9 plus 6 is 15. Okay, let's try this one. We have, this one shouldn't be as bad. We have 2x plus 8 is equal to 4x minus 18. Okay, now no fractions, no brackets, so we can skip the first two steps. We can't simplify the left side. We can't, there's no like terms there, there's no like terms there. But now we start doing, we want to get it so that we only have one x term on here and one constant term over here. So one way you can do that is something I call making a checklist. So if I want x terms on the left side, constants on the right, let's just do a little checklist, see which terms we have to get rid of. So if it's just variable terms here, that's okay, but that's not okay. I don't want the plus 8 there. The 4x over here, this side I just want constants or numbers. So I want to get rid of that, and the minus 18, that's okay. So basically what I need to do is I'm going to do two separate steps. It doesn't really matter which order you do them. The first one I'm going to, well, one of the ones has to be subtracting 8 from both sides, and the other one would be subtracting 4x from both sides. So it absolutely does not matter which order you do this. I'll do the 8. And you could actually do them both at the same time, but it can get a little bit messy. So I'd probably advise against that unless you're very confident. So let's just do the minus 8 first. So I'm just doing that to both sides. If I simplify, you can see these cancel. So I get 2x equals 4x. Minus 18 minus 8 is minus 26. Okay, and now what we're going to do, remember, we wanted to subtract 4x from both sides. Okay, so there's my minus 4x that I've added. Okay, now these, the 4x there and the minus 4x, they cancel. Okay, so I have a minus 26 left over there. Over here I've got 2x minus 4x, so I'm going to have something x, that's going to be 2 minus 4, which is negative 2. So be careful, that negative sign is very important. So now when we get rid of the negative 2, we have to divide by negative 2. I'll just put my answer over here, so those two cancel out. Negative 26 divided by negative 2. Negative divided by negative is positive, so x equals 13. And again, you could check that by plugging it in. I'm fairly confident it's right. Okay, we've got 2 more examples to do. Okay, so number 10, we have 3k over 5 minus 6 equals k over 3. Okay, so This one's a little more complicated because we've got like two fractions, although we've seen that before. We've also got two variable terms here. So again, going through our checklist, the very first thing we want to do is take care of the fractions. So we look at the two fractions we got to fix, and we have a divide by 5, divide by 3. So we're looking for what number, what's the smallest number that we can divide by 5 and also divide by 3. Well, that number will be 15. Okay, so what we're going to do is multiply all three of these terms by 15. So when I write that out, the 15 for the fraction terms just goes on the top. So I've got 3k over 5 multiplied by 15. Don't forget about this. You have to multiply that by 15. It's a very common mistake. And also this gets multiplied by 15 as well. So we have a 3 there. So again, just like before, we're going to simplify 15 divided by 5. It doesn't cancel out, but it does equal a nice integer. 15 divided by 5 is 3. So replace both numbers with a 3 on the top. There's really a 1 on the bottom, but it doesn't really matter for us. And the same thing here, 15 divided by 3 is actually equal to 5. Okay, that looks a little messy, so let's just kind of simplify what we just did without doing anything too new. So 3 times 3k is 9k, and that's all over 1, so it's just 9k. Negative 6 times 15 is minus 90, and then we have just 5k over here. So in one step, we've turned it into a much nicer looking equation, which we're going to solve. So in this case, I can't simplify left side or right side, so we do our little checklist. The 9k, I want the k's on the left side. I don't want the negative 90 here. I want my numbers over here. And the 5k also should not be there. So again, what I'm going to do, I'm going to subtract 90 from I'm going to add 90 to both sides, and then I'm going to subtract 5k from both sides. And I'm going to do that two separate steps. So I'll do the plus 90 first. Okay, and like usual, those two cancel out. I'm left with 9k equals 5k plus 90. And now I'm subtracting that 5k that I didn't want there. So 9k minus 5k equals 5k plus 90 minus 5k. Okay, that 5k and the minus 5k cancel out, and I can combine these two now. 9k minus 5k, well, it's going to be a k, but it's 9 minus 5 of them, so that's 4k is equal to 90. And now we're down to the last step where we get a multiple of the variable equals a number. Well, to get just the variable, we divide by whatever that number in front is, which is 4. Divide both sides by 4. Those cancel out. And 90 divided by 4, well, that's not a nice integer. It actually works out to, well, you could simplify it to 45 over 2, or it actually is exactly equal to 22.5 as a decimal, and that's satisfactory for sure. What I don't want you doing is, if you get a decimal that goes on forever on your calculator, don't change it to a decimal. Leave it as the simplified fraction. So it's either 22.5 or 45 over 2. Both of them are okay. Okay, so if you remember, the very first started talking about, if we go back to our first page that we were working on, I came up with this scary looking linear equation. Well, now I think we're ready to do that. So let's give it a try. Might need a bit more paper for this one. So this is example 11. So let me just write it out again. 4x minus 1 over 4 plus 2x minus 1 over 5 is equal to 2. And like I said, this would be really pretty much impossible to guess the answer. And in fact, the answer is not even a nice integer. So, okay, so if I'm looking at my step by step, the first thing I notice is fractions. So what do we do with fractions? We want to get rid of them by multiplying a number that gets rid of the 4 and the 5. So since we look for the lowest common multiple of 4 and 5, what's the smallest number that can divide by 4 and divide by 5? Well, that would be 20. Okay, so I'm going to multiply every term by 20. I'll just put those up here. Now, 4 and the 5 are down here. Now, you have to be a little careful here, because if I just put 4x minus 1 here, it looks like I'm just multiplying the 4x by 20, but really I'm multiplying the whole top. So I have to put brackets around there and up here as well. Very important. Okay, so when I see this, okay, I'm not going to, I still haven't got rid of the fraction, so I'm not going to expand it. I'm not going to get rid of the, brackets yet, but I can see that 20 divided by 4 is really 5. So that gets replaced with a 5, and 20 divided by 5 is really a 4. Okay, so that's going to allow me to write the next step. 5 times 4x minus 1 plus 4 times 2x minus 1 is equal to 40. So we successfully got rid of the brackets, got rid of the fractions. Now we get rid of the brackets. So we have to multiply the 5 with both of these, the 4 with both of these. So I'm going to get 20x minus 5 plus 8x minus 4 equals 40. Okay, now you can see I've got a couple of x terms on the left side, a couple of constants. This would be our, this is what I meant by the third step, where you simplify both sides by, you're just looking at that one side and trying to simplify it. You're not doing subtracting things from both sides, you're just simplifying. So if I look at this, I've got 28x, if I put them together, and that would be a minus 9 equals 40. And all of a sudden it's looking like this is something we can do now. Okay, so again, when we get to this step, we see, well, I don't want the minus 9 there because I want just x here. So I'm going to add 9 to both sides. Okay, those cancel out. Get 28x equals 49. And now we divide both terms by 28. Okay, and 28 divided by 28, this always should cancel out. Okay, and 49 over 28, if you do that on your calculator, that's, well, you'll get a decimal. We could, what we could do is you see that, well, both of these numbers I can divide by 7, so I can reduce this fraction. So that would reduce to 7 over 4, or if you did the division right away, you'll see you get a 1.75, which is exact. So either one of these answers would be acceptable. Okay, so we've gone through quite a few examples today. Hopefully this helps you be less anxious with solving equations. Now I did want to talk about the very first page. I talked about solving linear equations. Okay, so there's all sorts of equations in math. What makes these linear equations is that the variables that we use, they don't have any, first of all, they don't have any exponents like x squareds or x to the power 3, and also there's only one variable. We may have more than one of those variables. In this case, like we have x's or y's or w's, we may have more than one of those, but we don't have x's and y's in the same equation. So that's what linear equations are. And hopefully these examples help you become confident and know how to solve equations.